Okay, so we're going to start this problem by using a picture to really understand what's happening here. First, we have the train car. Then we have the load that's being added to it. The car starts with an initial speed to it, while the load starts at rest and is placed onto the car. So let's write out our initial conditions. We have a car with a mass of 12,600 kilograms going at 18 meters per second, and the added load is 5,350 kilograms, starting from rest at 0 meters per second. So now let's get into the meat of the problem. For now, let's call the car object 1 and the load object 2. Through the concept of conservation of momentum, we know that the momentum of object 1 and the momentum of object 2 before the collision and after the collision is the same. Therefore, P initial of both objects is equal to P prime or P final of the objects moving together after the load is added to the car. So since we know that momentum is equal to mass times velocity, we can use this concept to find the final velocity of the two objects after their collision. So now we're going to write out the equation. We're going to have mass of object 1 times velocity of object 1 plus mass of object 2 times velocity of object 2 equals the total mass of both objects combined times the velocity of those objects together in the end. Then we're going to simplify that to momentum of object 1 plus momentum of object 2 all over the mass of both objects to get the final velocity. So now we're going to substitute in our values. We'll have 12,600 kilograms times 18 meters per second plus 5,350 kilograms times 0 meters per second, which cancels out. And that all over the mass of both objects, so 12,600 plus 5,350 kilograms. Finally, you get that the final velocity of both objects together is 12.6 meters per second. And that's your problem.